All right. All right. Hello, everyone. My name is Mathan. I'm one of the course reps for B07 this year. And I'll be starting off today's seminar for CSCB07. All right. So, can you take off the annotation? Okay. Yes. All right. Now we're good. All right. So I'll be covering solid design principles and clean code for today. To start, first design principle is the single responsibility principle, also called SRP. This principle states that a class should only have one responsibility and one reason to change. So any class you define should have only one purpose, and the only reason why you should change that class is to better serve that purpose. Now, to show this through an example, I have this piece of code. And my question for you guys is, how is SRP violated here? So I'll give you guys a few minutes to look at it and tell me how you think we violate the single responsibility principle. I'll answer you guys first. Okay. You get anything in the chat? All right, it's fine. Okay. Well, the way SRP is violated here. So take a look at this class, right? It's called text manipulator, right? So you have a string field called text, and you have these two methods called append text and find word and replace. And if you think about it, those are two ways of manipulating text. At the bottom here, you have this function called print text, which prints out the text field, right? So if you think about it, this class both manipulates and prints text, which are two actions. So the text and to conform to SRP, the text manipulator class should only do one, right? And that's pretty much why SRP is violated here. You're doing two different functions. You're doing two different actions in the same class. A better way to think of this is if you wanted to change this text manipulator class, you'd either do it for changing how the text is printed in the print text function, or you change how the text is manipulated in append text and find word and replace. And that's two reasons why you'd want to change the text manipulator class, not one reason. So that's an SRP violation. So I hope that makes sense. Any questions? All right, so how can we refactor this code to not violate SRP? I'll give you guys any ideas for this. Pardon? Wait, what would you see from that? Wait, what were you? What do you find the code that you want? The same functionality, it's remain, but you would just want the base in your program or in your file suite. Yeah, right? That's what refactoring means. Do we get anything? Said creating. Okay, someone in the chat said create another method for the second part of printing. I think what you guys actually meant was create another class, because that's what you do. Essentially, you take out the text printer or the print text method from text manipulator, and you create a new class which I call text printer, which takes in a string text field, and it prints out that text field. And all we do is just move the print text method to the text printer class. So now you have one class which serves the purpose of manipulating text, and another class which serves the purpose of printing text. And that helps you conform to SRP. Does that make sense? All you do. It's not that complicated. It's just each class does one thing. That's pretty much the idea. So, any questions on that? You guys are good? All right. One thing to note, like when you have a class with a bunch of with a bunch of methods, keep in mind that like not every method serves a different responsibility. You should use like your context and intuition for determining which methods fit within class and like serve that class's purpose and which don't. Generally, it should be relatively obvious. So like, because I would say this is the easiest solid principle to understand and what find and like pick out. Um, and like one more thing I want to ask you guys is um, why is SRP so important with respect to clean code? There's a lot of answers to this. I just want to hear maybe some of your guys' ideas. You guys have ideas? Yeah, that's one way. Yep. Um, yeah, that's definitely one. Another one is like if each class has like one like purpose, it's just more easy to like read and understand. And with that, like this is directly from the slides. Um, the reason why SRP is important is because it ensures you have clean classes, which means your classes should be small and have high cohesion. You guys don't remember? Cohesion is the degree interconnectedness of elements within a module. And this is something you should remember for the exam because this is straight from your slides. And it might come up as like a short answer or multiple choice. All right.
Sunset, it allows you to photocopy.
Uh, I believe that's also true, technically. All right. Um, I guess that's all for. Oh, okay. All right. Um, okay, that's all we have for SRP right now. So moving on, the next solid principle is the open close principle, which states that software entities should be open for extension but closed for modification. So any code you write, if you want to add any program you write, if you want to add a new feature to that program, you shouldn't have to modify any existing lines of code. All you should need to do is just add new lines of code to implement your new feature. That's essentially what this principle states. And here's an example of it. So for this example of code, can you guys tell me how OCP is violated here? I'll wait for your answers, you guys in person. That. Um, so someone in person just said, if you wanted to add a new shape, you'd have to edit uh, the function not get num size in the shape info class um, to account for like whatever the name of the new shape is, right? And that's right. So yeah, the code above violates OCP because for any new type of shape we add a class for, we need to modify get num size in class shape info to account for the new shape class and its number of sides. Like we'd have to return a new number as well. So like that's just so you're modifying your code, not adding anything new, right? Okay. Um, Now how can we refactor this code to not violate OCP? Any ideas for this? Yes. Um, so what a person said is that you can create a new interface or like abstract class called shape and have each shape extend from it. That's essentially what the solution is. So since we already have shape info, you can just turn shape info into an abstract class and inside shape info was get num size. You can turn that into the abstract method. And then for each shape, you can extend from shape info. So you can then implement uh, have different implementations of get num size for each shape class you add. And that way your your program satisfies OCP. So I hope that makes sense. Yeah, good. So moving on, we have the third principle in solid is the Liskov substitution principle, also called LSP. And by definition, this principle states that subtypes must be substitutable for their base types without altering the correctness of a program. So what this essentially means is that if you have an instance of a superclass, you should be able to replace that instance of a superclass with an instance of one of that superclass's subclasses, if that makes sense, right? And when you do that, it shouldn't alter anything with like the expected behavior of the code. And by superclass here, I mean like I mean like also like a normal parent class, it could also be like an abstract class interface, because keep in mind you can have like an instance, I guess, of like a abstract class or interface when passing it in like a function, or just having it as like a field in like a class or something, right? If you guys don't remember why that works, you guys, I believe will be covered. You might cover it later, right? Abstract classes and everything.
Yeah, we'll cover that after.
Yeah, that will be covered later if you guys forgot. So now for an example, here's a piece of code. I'll give you guys a few minutes to look at it and tell me how you guys think this program violates LSP. Have an idea?
I think like part is not they get really bad in this. It's not about that. You will make it horrible.
Yes, that's correct. Yeah. So as someone in person just said, because you have your car object. So when you call turn on engine as a car object, you expect your engine to be turned on, and that's how the implementation is shown here, right? So, but then if you were to replace that instance of a car object with the electric car object, while still expecting the same behavior of the car object, that the engine will turn on, what happens is, like, by the implementation of turn on engine in the electric car class, nothing happens. So you don't get the behavior you expected when you replace an instance of electric car with car. And thus you violate the Liskov substitution principle here. I hope that makes sense. Any questions? All right. So moving on, how can we refactor this code to not violate LSP? I'll take any ideas. You guys can type in the chat. You guys can take a minute, look at it, maybe come up with something. Nothing so far? All right. Yeah, that's okay. One person has. All right.
If that are undevelopable. But then this really knows are the extent of like maybe something like based on vehicle which has and stuff like the acceleration. But nothing about with that. Yeah, really that's requirements. And when the vehicle enters a car.
All right. So one solution that someone in person just came up with, like, is that you can create maybe an interface called vehicle, which has the method for accelerate, and then you would implement that method, and you would have probably a different interface for engine, and you implement the interface with the turn on engine method and the interface with the accelerate method for car. And then for electric car, you would just put the interface with the accelerate method. And that is one solution. The solution I came up with was, okay, you have your car class, right? And you had your turn on engine method in that car class, right? But it's clear from electric car, which is a subclass of car, that like not all cars have engines. So what you could also do is create a new subclass called engine car, and then just move the turn on engine from the car class into the engine car class. That's also another solution, a way of approaching things. And doing this is good because you also preserve the whole functionality of there being some type of car object that can call turn on engine. Because if, for example, if you just happen to delete the turn on engine method from car and thus deleting it from electric car, you no longer have any car object that can call turn on engine. So that kind of changes the functionality of the code. And when you refactor, all you want to do is change how the code's written, not any of the functionality. So that's why like I'd say this is like a really good solution for this problem.
Oh, yeah. What?
Yeah, so like here LSP is not valid because because since if you look at the car, um, if you look at the car class, everything in that car class is inherited by the electric car and engine car without any like problems, right? We're not overriding any methods or anything, right? So you can replace any instance of engine car class or electric car class with car, and thus you satisfy LSP. All right. Now moving on, the fourth solid principle is the integration. Um, that is wrong. It should say interface segregation principle. When we give you guys the slides, we'll fix that. And by definition, this principle states that clients should not be forced to depend upon methods from an interface they do not use. And when we say clients here, it's just whoever calls the method defined in an interface. And what this essentially means is that like if a class uses an interface, it should have valid implementations of all methods defined in that interface. If this isn't the case, then the class would have at least one unnecessary method with an invalid or empty implementation. And then like there's no reason for a client to call that. So that's essentially the idea. And to better show this through an example, here's a simple piece of code. Can you guys tell me how this example violates ISP? You guys in the chat can just type in the chat and yep. So basically like car interface is used by electric car class, but it doesn't actually use the turn on engine method. It just throws an exception if you're calling turn on engine from the electric car class, right? And thus a client of electric car class would never realistically call turn on engine and ISP is violated. And just a simple way of thinking about it is like, are all the implementations of the methods in the interface, are there valid implementations in the class that implements that interface? That's just if all of them are implemented correctly, then ISP is not violated. If all of them are, if there's something that's not implemented correctly, then you have an issue with ISP. I hope that makes sense. All right. So next up, how can we refactor this code to not violate ISP? There's a really simple solution to this. That's like a hint. And you don't have to do much. Yes. All you technically need to do is get rid of the turn on engine method from the interface car. So you don't need to then implement it to electric car and like and throw an exception, right? Yeah, so like here, that's just a quick fix, just remove turn on engine entirely. And we can do this because there's no other classes which need to use turn on engine. It was just stated in the interface. So you're never gonna have like, but there's no object using it, right? So but like if you did have another car class that did need to use turn on engine, then in that case, you might want to move turn on engine into like some sort of interface called engine and implement both car and engine into each of those like car classes, if that makes sense. Any questions on that? Yeah. High speed interface. Like LSP, like substituting, yeah, the superclass can include interfaces and abstract classes. So to repeat that question, someone asked what the difference is between ISP and LSP. And for LSP, it's the idea of like being able to substitute like a subclass into a superclass. If you're able to do it with no issues, then you satisfy LSP. And then with interface segregation principle, um, this just has to do with interfaces alone. So it's not all kinds of superclasses. Because for LSP, recall when we said superclass, I included parent classes, abstract classes, and interfaces in that with interfaces. And yeah, I hope that makes sense. Right. Okay. And the final solid principle is the dependency inversion principle, which by definition means high-level modules should not depend on low-level modules. Both should depend on abstractions. Abstractions should not depend on details. Details should depend on abstractions. So I know that was a lot to hear. What we mean by abstractions are just interfaces or abstract classes. And what we mean by details are specific implementations. You shouldn't rely on specific implementations of an abstraction when defining your abstraction. Just keep things general, right? This is better. This is like I'd say the solid principle that's best shown through example. Also, when we say high-level modules and low-level modules, high-level modules are like modules that are more likely to be like called on by a client, whereas like low-level modules are probably like modules that are like used by other functions, if that makes sense, right? I just want to highlight that distinction. So now, for an example, here is an example of code. I'll give you guys a few minutes to look at it, and you guys can maybe come up with some possible ideas for how it violates the dependency inversion principle. And you guys can just type in the chat. Yes. Yes, that's pretty much it. Um, so yeah, the person in chat is also right. Um, basically, as someone just said, um, okay, if you look at payment processor, it's you can see this is like, I guess what you'd say the higher level module, because you can imagine, a client using the payment processor class to call process payment, and you can say process payments uses the PayPal payment dot pay class or the dot pay method from PayPal payment. So this one's the lower level module because this one's used in the payment processor class, right? But because this means this is a higher level, this is lower level. A higher level module is using this, it depends on this lower level module, and so DIP is violated. Yeah. Um, so I hope that makes sense. And I guess I'll move on to how you would refactor this code to not violate DIP. I'll give you guys a few minutes to look at it. Maybe type in some ideas in the chat. I guess you can think of it as like PayPal payment being like, you think about it as like a really specific kind of thing. Maybe there's a bunch of different ways to pay, right? So I guess that's one way to think of it. I guess like you wouldn't get something um this general. It would be a lot more specific for you guys. So like if you think about like PayPal payment, something really specific. Um, so like when you use it in a processor, it's kind of like you're like if you change anything PayPal payment will like affect payment processor. That's like the main issue with high level things used relying on lower level ones and not abstractions. So um yeah, someone just wait.
Oh wait, I get it now because PayPal is stupid type of pay.
Yeah.
So like when it's not PayPal payment, it's not like transactional payment, then it's okay because it's not the kind of
Yes, that has to do with the solution. All right, good. Yeah. So um yeah, so essentially PayPal payment, when you see it, look at it, it's a very specific type of payment, right? Right. So you think about it, you might have like other kinds of payment, but like you're depending on this sole type of payment, right? And because of that, you violate the IP because this is like lower level, this is higher level. And so that's why when you refactor this code, what you could do is you can create public like an interface called payment method, which has that pay method that was defined in PayPal payment, right? And then for any, and then you'd have PayPal payment implement payment method. So then it would need to implement the pay method. And then in payment processor, you'll have like a field for payment method instead of a field for PayPal payment, and you'd call payment method.pay. So for whatever um, implementation of payment method is like the instance when you define your payment processor object, then it will call that implementation of payment method, right? Or the pay method. And that's essentially the whole idea behind this. Does anyone have any questions? Are you guys good? Okay. Doesn't look like there's any questions in chat, so I'll move on. All right, now the last thing, why DIP is so important with respect to clean code. I'm just going to go through with this. The answer from the slides is like it reduces coupling, the degree of interdependence between modules. So like having a lot of interdependence between modules is really bad because if all the modules depend on each other, if you change one module, that might result in an error in another, that might cause an error in another, and it might just cause a cascading like flow of errors. And that's really bad. So that's like the whole idea of why DIP is so important, right? Um, and that's all the solid principles covered. So like before I end off, I have like one final problem. So I'll give you guys like, a few minutes to look at it. I want you guys to maybe like think about what solid principles are violated here. And I'll do this. Let's first try to see what solid principles are violated here. And then I'll ask about refactoring the code after. So I'll give you guys like a few minutes to look at it. I'll give you 1 second. Just a hint, there's 3 solid principles which are violated. You guys have one? Yeah. Yeah, so ISP is one of the someone just said ISP is one of the solid principles violated here. That's one, right? I'll just go through with it. So yeah, you can see ISP is violated here because here you have interface with drive refuel sale in class car, which implements vehicle. You have you see that the implementation for sale, it throws an exception, so it's not implemented in a valid way. So, and you see the same thing in bicycle and boat. Exceptions are thrown for refuel and sale for bicycle, and for boat, drive throws an exception, right? So like if you have an instance of vehicle, right? Or like essentially there isn't a when you have you're gonna when you have like an instance of vehicle, you expect all of the drive, refuel, and sale functions to be implemented correctly. But in every single one of these classes, you don't have a single one where all 3 are implemented in a valid way. So that's why ISP is violated. The LSP is also violated. Yes, that is also right. Because if you think about it, uh, when you have an instance of vehicle, right? And you want to replace maybe like, let's say car with that instance of vehicle, right? You might have, the problem is the sale function is not, there was an exception. So that's the issue. So yeah, so that's essentially the reason why that doesn't work. So I'll just put it aside. So yeah, substituting any class that implements vehicle interface breaks functionality as calling an unsupported method such as sail on a car object or drive on a boat object would result in an exception. So you can't necessarily substitute like car for vehicle perfectly, right? And then the last one was OCP because if you think about it, if you wanted to add like a new vehicle type, say plane, you would have to. edit the interface vehicle, add like a fly function, then you probably have to edit the car class, bicycle class, and boat class to throw exceptions for like the fly function that you add. So that's basically why OCP is violated here. So, any questions on that? Is that good? All right. So last thing is refactoring. So I'm just going to go over how I refactored this code. So essentially all I really did was split up the vehicle interface into three different interfaces for one called drivable, which has the method drive, one called refuelable with the method refuel, and saleable with the method sale. So for car, we implement drive and refuelable because those are the only methods that car can have out of the three. For bicycle, we only implement drivable because that's the only one this can implement, the only method that's valid. And for boat, it's refuelable, saleable because those are the only two methods that that a boat object can execute. And like by doing this, we resolve ISP, we resolve ISP pretty clearly because now we have separate interfaces. OCP is no longer violated because for any new vehicle, which might need um, a new method, you can just create a new interface for it. And then LSP is no longer violated because you no longer have any interface, which for every interface, um, for each object, you implement only the interfaces that have like valid implementations for that class, if that makes sense. Does anyone have any questions? All right. That's all for me today. So I'll be passing the mic over to my uh, friend, Frans. And he'll be covering design patterns.
Yeah, before I cover design patterns, do you guys have any questions regarding like solid as a whole? If you guys do, like, please type them down in chat. How do I? Okay. Uh, if not, then we'll start with design pattern. So, is the audio fine? All right. So in class, Professor Rawad goes over 6 design patterns, which are strategy, observer, facade, singleton, adapter, and factory. So today, we'll be going through like an example for each one of them, so you guys can get familiar to like different ways of how these design patterns will look like. So, okay. So first one will be strategy. We'll go straight to like some practice questions since you guys seem to be prepared already. So, um, take a minute to look at the code here. And then what you need to do is to refactor the following code so that um, you can easily add a new date format. So right now it's printing in a year, month, day. You want it to print in a day, month, year format without having to modify the date class each time you do it. We'll give you like maybe 4 minutes. I would also suggest getting a pen or paper and try to practice writing down the codes too, because then that's what you'll be doing in your exam. If you have any, if you guys are ready, let me know in the chat, or you guys just raise your hands up if you're ready, then we can discuss together.
have a big process that lets what happens. Like,
Okay, so we'll take it up together. So just as a refresher, this is how a strategy design pattern looks like. So what you need first is an interface for the strategy that you will be using. So it will be this box right here. So you need an interface to use an interface, and then there will be like some concrete strategies that will implement those interface. So here's how it will look. So first of all, you need to create an interface called, I guess, date format strategy. And in that interface, there will be a method that every class that implements this interface needs to implement. So it will be a print date, and it will take in the argument year, month, and day, right? And then for one of the strategy is to print it in the year, month, date format. So we call it class YMD strategy, which implements our interface. And then it will also implement the method here, which is print date, and then it returns that in the YMD format, right? And then if you want to have another strategy like the month, day, year format, then you do the same thing, but then here it returns month, day, then year. So I guess like the tricky part for this the strategy method is in modifying refactoring the class date. So here, first you want to add a field in class date to store like the strategy. And then you will need a method to like set the strategy in date. So you need to know, you need to be able to like control what strategy to use in date, right? And then in the end, like the method print, the functionality of method print will depend on which strategy you set previously. So then when you use this date class in the main, it will be like this. So you instantiate a new date. You put in like the argument to instantiate a new date, which is the year, month, and then day. And then you set the strategy to, I guess, year, month, date first, and then when you execute date.print, it will run this code. It will print the YMD strategy.print date. Is it clear? Yes. Question.
I think it's not planning to focus on certain strategy. That's like,
Yeah. Yeah. There are like different ways to implement, but then one of them is this. If you guys want more examples, I suggest looking at like the past examples, the past practice examples. There's also a code example given by Rawad, right? And there's .zip file. So, yeah. Question. In the YMD strategy. In the YMD strategy, do we have to make an empty constructor? Sure. Yeah, I don't think you need a constructor for the YMD strategy. Okay. Is there any other questions?
No, that's all.
That's all?
Yeah.
Okay. All right. So next one will be the observer design pattern. So this is more like a fill in the blank type of question. So the code above needs to automatically notify the observer when the temperature is set above 30 degrees Celsius. So you need to complete the missing code. We'll give you a while to like complete it, and then we'll do it together. Like just read through the questions first. Um, okay, so hopefully you guys already read the question. Let's answer it together. Okay, so hint. So this is what the diagram for observer design pattern looks like. So in an observer design pattern, there's two main things, right? So there's a subject and there's the observer. Subject is the class that contains a field that I guess constantly change, and observer are the class that wants to be notified if something in subject changes. Okay, so if you go back to our previous example, can anyone tell me who is the subject and who is the observer? Oh, it's obvious, but you know, who is the subject and who is the observer? Yeah. So yeah, so obviously the observer will be the observer temp, and then the subject will be the weather alert. Yeah, that's correct. So okay, let's play in one back. So first of all, we need the interface for the observer and the subject. So these are usually the methods that you need to implement in the observer and subject. So for observer, there's always an update method that runs that gets triggered whenever the subject is updated. And then for the subject, there are usually these four methods, which are register observer, which means it adds the observer to a list of observers in the subject class. Notify all observer. This will be triggered every time the state of subject is changed. There's also a method called set state, which changes the state, and then get state, which returns the value of the state. So like different examples have different implementation, but usually these four are like the basic methods that will be found in as the subject class one way or another, right? So weather alert, which is the subject, implements the subject interface. And then it's important to note that there's usually always a field that represents the state that you guys want to observe, which in this case is temperature, and also a list of observers. This is how the class keeps track of who is observing that class, right? So the constructor for the weather alert would be to initiate a new array list of observer. So right now, currently, when you just made it, it's empty. And then in the method register observer, you want to take in the argument of like an observer, and then you want to add them to like the list of observers. For get state, again, it's very simple. You just have to return the temperature. And for set state, you want to set the temperature to like the value that that you pass. And then it will also automatically triggers the notify all observers. Okay. And then the notify all observers method will loop through the list of observers in the observer list and then invoke the dot update in that observer class. So far, so good. Okay. And then now in the observer class, again, don't forget to implement the interface. You need the subject you need the subject as one of its field. And then when you construct the observer class, you need to set the subject field, and also don't forget to register yourself, or in this case, like the observer, to the list of observer in the subject class. So in this case, it's subject dot register observer. This. And then this one is the update method is usually the one that varies depending on the context of the question. But in this case, we only want the observer to be to send out a notification if the temperature is above 30 degrees Celsius, right? So in this case, update will be invoked every time the temperature is changed because of the set state here. However, if you want to control whether there is a warning only when the temperature is above 30 degrees Celsius, you can add this piece of code. So if subject.getState returns the temperature is greater than 30, then use print out the hot weather warning. Okay. Otherwise, it will just return nothing. So a quick question for you guys. What is the advantage of having this logic of like greater than 30 in the observer class rather than in the subject class? Any idea? Right. So someone said so that the subject can have like multiple types of observer, and that's correct. If we put this if statement in the set state, then it will only, I guess, like notify all observers only when the temperature is above 30 degrees Celsius, right? But what if we want to create another observer class that notifies when there's a cold weather where the temperature is below, say, like negative 10 degrees Celsius? So if the if statement is in the subject class, then we will end up having to make another subject class, right? But if it's in the observer, we can just create another class called, say, like observer low temperature, and then copy everything, but only change this update part. So if subject.getState less than 10 degree, then you can give a cold weather warning, right? So it makes our code, I guess, open to extension, but closed for modification, right? So back to solid. Anyone, any questions? No? Okay. Next one is facade. This one is probably my favorite one because it's the simplest one. So question will be, during party time, Bob wants the lights to turn on, the speakers to turn on, then increase their volume, and then the AC to turn on. Use the facade design pattern to achieve this. So it's really easy. Since it's so simple, let's just like immediately take it up. Okay. So the main function of a facade design pattern is to hide the complex processes from the client. So in this case, the client code is in main. So we don't want the client code to have like light.turn on, then speaker.turn on, and all those many complex steps. So we can hide them. So we can hide them in like a class, in a class called party facade. Okay. So what you do here is you create a party facade, and then you have the fields that has all of this subsystems or subclasses. Then in the constructor, you do like the regular constructor stuff. And then in one of the method, you compile all these like complex steps so that in the client part of the code, you just have to invoke like one of this method, which is the party time method, and then it will run like all these complex steps of method for you. Okay. The implementation is quite simple, but it's quite powerful so that you don't have to like write all this in the client code side. Any questions for Facade? It's quite straightforward. No? Okay. Oh, resuming. Okay, singleton. So this one I'll give you guys a few minutes to solve because it's pretty simple. So this is a faulty implementation of a singleton design pattern. Find the mistake and fix it. Give you guys a few minutes. Anyone notice where the mistake is? Okay. All right. Okay. Yep, that's correct. So someone in chat said that the constructor should not be public for singleton. It should be private. Do you guys want to explain why? Okay, yeah, someone said it should be private so that it can only create one instance and provide a global point of access to it. That's correct. If the constructor for manager is public, then anyone can invoke new manager, the constructor new manager, and then create an instance of manager, right? Then we can't ensure that there's only one instance of manager here. So that's right. So to fix it, you just change this public to private. If this mistake is not fixed, write a client-side code where you can generate multiple instances of manager. Last final. Yeah, we need to make the class final. If anyone wants to try the solution for B? Okay, if not, we can take it together. So this is the solution. So if the code is not fixed, you can do manager m1 manager.get instance. So this will create a manager. So this will create a manager instance, right? Because you invoke this get instance, then manager is equals to null because this is the first time we run it. And then we get a new manager. But then since this one was public and you haven't fixed it, you can call new manager and you get like a second manager, which defeats the whole purpose of singleton. Or you can just, call new manager twice since it's public, right? That's why it's very important for this to be private. So be careful for this. It's a really simple design pattern, but I think this is where a lot of people might forget to set it to private and lose stupid marks. Okay. Okay. And then we have adapter. This one is a bit long because I can't find a shorter example, but I'll give you guys like a few minutes to read the code first, and then we'll take the solutions together. Right. So this code, there is a printer interface with the method print. And then there is also an old printer that is not compatible with the current printer interface. So this one has a method old printing instead of print, right? But then in the client side code, we want to use the printer interface instead. So this is where adapter is very helpful. When you have a class that does something that you want, but then it's not compatible with the interface that you use, you can create an adapter class to bridge uh, that class and interface together. Okay. So in this question, yeah, your main printer broke. If you have an old printer you can use, however, it's not compatible with the printer interface. So your task is to create an adapter to bridge the gap between the interface and the printer. So you can use the old printer. And we can discuss the solution together. Here it is. So this is the diagram for an adapter. It's quite straightforward. So this is the client, which is you, and then you're used to using this target interface, which in the questions case is this one, the printer interface. And then we have the adaptee, which is the old printer that is not compatible with the interface, right? So we need to create this class so that we can use this adaptee through using the methods in the interface. Okay. So to answer like the question, you just need to add this one class. You can call it old printer adapter, which implements the interface that we want to use. And then it has a field of like the adaptee. Constructor just set like the field adaptee. And then you'll also need to implement the method in the interface. So this one, right? So it's public void print. You take in the string message amount. And then that that method will run the adaptee, the adaptee's method old printing. Okay. This one is quite simple. Is there any doubts? No? Okay. And then last but not least, it's the factory method. This one doesn't have a question, so it's just an example of a factory method. So in this example, we want to create a factory to make instances of round buttons. Okay, so we have an interface called button. It has a method of who am I. It basically just prints like the identity of that button. So a class round button implements the interface button. It has field ID number. It has constructor to like set the ID number. And then it overrides the who am I method so that it prints a round button with the ID number. Okay. Yep. So for the factory, you need to create an interface for factory, which has the factory method, which has a method called factory method or anything you want to call it, but it returns the button instead because you want to make buttons, right? And then you have the concrete class called round button factory, which implements this factory interface. And then it has the field of the ID number. And then for this one, it randomly generates a 5-digit ID number and set this field. And then when you run the factory method, you will return a new round button with the ID number. So if you focus on the client side code, if you want to make a round button, you just have to instantiate a new factory, and then you do factory.factory method, and then you'll get a round button, right? So why is factory method important? Um, if you want to create something simple, you can just create a new instance of the round button, right? But then sometimes a class, instantiating a class can be complex. So in this case, to add the like to simulate the complexity, we have like this random ID number. So using the factory method, the client do not have to worry about uh having like this ID number to instantiate the run button. They just need to um call the factory method, and then like those complexity will be handled by the factory. So the client is free from like the complexity of generating a round button. Um, is that clear? Any questions there? Yep. Um, right. So yeah, that's for the design pattern. Any questions for design pattern? Any questions about design pattern before we move to testing?
I don't think so.
No? Okay, we move to testing then. So uh, testing is there's quite a lot of things to cover for testing, but then Rawad already covered the RIPR model in the review seminar, right? And I think his explanation is quite thorough, so we will not be covering our RIPR model. We'll just be covering this JUnit testing. So I'm sure you guys are quite familiar with JUnit testing because you guys did the B07 project already. So this one should be pretty easy for you guys to solve. So the question is to write the minimum amount of JUnit test cases to achieve full statement coverage. Full statement coverage means you need to make sure that each line of the code is run at least once. So, and make sure that each test cases needs to use some form of assertion. Assert equal simple. We'll give you guys we have 3 minutes, I think should be enough to think of like the minimum amount of test cases to achieve full statement coverage. You can write down in chat too if you think what you think is the smallest number of JUnit tests needed to get a full statement coverage. And we'll just all right. We'll go through the solution pretty quickly. So the answer is you just need two test cases for this. So first of all, for the first test cases, we run this code, but have an empty list of doubles. So in this case, it runs line 1, and then it goes to line 2, However, A's length is 0, which invokes which triggers these two lines, line 3 and line 4, and returns max. In this case, max is double dot negative infinity. Then we assert equals so that expected, actual, and expected is the same. And then for the second test case is you set the list to only contain odd numbers. And then what that will do is it will skip this code line, so this code, and it will go here. So line 5 will be there. Then it will go through this while loop. If A index is greater than max and A index is divisible by 2, then it goes here. So in this case, A index is definitely greater than max. Greater than max. Oh, wait. Wait, that's a mistake. Yeah, yeah, thanks. Sorry, guys, I think there might be a typo in this question. Sorry about that. So we'll just skip this question for now. Okay. Sorry about that. Okay, so let's discuss about Agile as the software development lifecycle now. So it's an MCQ, so it should be easy for you guys. All right. So which of the following statement is incorrect? Okay. Agile is iterative, waterfall is not. The cost of an agile frequency is once per project, or agile project do not have a fixed timeline. So which one is incorrect? Uh, Yep, everyone is saying two. The cost of an agile project is fixed. That is false because agile is iterative, so you don't know you don't know how long or how short it will go through. It responds to changing requirements, right? So if the requirement change and you end up needing more costs, which is why the cost is not fixed. Next, it's pretty simple. Okay, which of the following is not a role in Scrum? Can you type it down in the chat? Oh, okay. Yep. Everyone is saying choice 4, which is reviewer. And reviewer is definitely not a role in Scrum. So it's simple. Next. And what is missing from the user story? I should be able to create a bank account. It's like yes. I see a lot of people saying actor object and result. So can you guys type in the chat of what a good user story would look like in this case? So yeah, someone answered. As a user, I should be able to make a bank account so that so that I can store my money or save my money. Yep, that's great. And then this one, Agile prioritizes planning and comprehensive document. True or false? Very simple. Just type it down in the chat. Two, yes, true. This is, I mean, it's false. So one of Agile Manifesto is responding to change over following a plan. So, yeah, the priority is not in planning and comprehensive documentation. Okay, so now I will hand over the presentation to David as he will cover the remaining chapters.
Hi guys, my name is David. I'm gonna take you guys to go through the material which be covered before the midterm. So, so in our expectation, most of the material covered before midterm will present it as a multiple choice questions or fill in blank or short answers. So, just to save some, just to change the plan a little bit, we will go over the OOP first, which is the object-oriented language programming. So if we have more time, we will go back to go through the chapter 1. Yeah, so we will start from the OOP. Okay. First thing first, there are two very important concepts for OOP, which is inheritance and the encapsulation. So I remember in my final exam, I think there is a short answer question which is asked to define what is encapsulation. For inheritance, inheritance just if, for example, you have a superclass, a general class, let's say person, and you're trying to make some extension or children class or subclass to it. So you have more specialized class, for example, employees, supervisor, or maybe just attendant. Yeah, that's basically how inheritance work. You have a superclass and you inherit some function from it and be more specific for a specific one. And for encapsulation, I think you guys go over the question from the singleton, the design Python one. Yeah, basically just you have private, you have protected, you have public, these three modifiers, accessory modifiers. So if it's a private one, which means you can only access it from the top level. If it's a public one, then you can access it from anywhere. But if it's a protected one, you can only access it from the same package or from its subclass. Okay, so let's talk about more specific about inheritance. So let's talk about casting first. There are upcasting and downcasting. So if you're trying to make a subclass to be a type of its superclass, then you're using the upcasting. For example, the person P is equal to new employees, which means you create a new you create an employee instance and then you upcasting it to a person. For the downcasting part, this is very tricky. Yeah, of course you're trying to bring back some. You're trying to um casting the employee to be a. Oh, sorry. You're trying to casting a person to be an employee, but you have to make sure the employee. I mean the person you created should be has a running type of employee. That's what I mean by the next sentence here. If the superclass object is not an instance of the subclass, there will be a running time error occurs, which means if you don't bring, if you're trying to downcasting, but you don't have a running type of the correct one, like for example, in this example, you have to make sure your P is has a running time of person, then you can trying to downcasting it. Okay, there is a true false questions, a really quick one. Casing an object reference will create a new object. The answer is false. Do you guys need some explanation here? maybe I can draw a memory graph. Hi, Christopher, can you turn on the light? Okay, so this is how it works. In the memory, oh, oops. Yeah, that's great. Yeah, I can see my screen. In the memory model, there are two parts in Java memory mode. Memory mode. So you have stack, and also you have heap. Right. For heap, all of your object will be stored in the heap, and all of your reference type will be stored in the stack. So basically what happened is let's use this example here. You have a P is an employee. Oh, wait a second. Yeah. And you have some method or you have some field right here. And you're trying to type this in from here. So this is a okay. Let's say you have the sorry, it's a T, the person, and have E equal. So everything in the stack are just reference type. Like they are just address. You can think of it as address, just a whole bunch of numbers. But the actual object will be stored in the heap. So basically what you do when you do the casing is, for example, here, originally, it's a P, it's a type of person, it's a class of person. When you're trying to type casing, you delete the kind of a link from the stack to the heap. You create a new reference type employee, and you create a link from the stack to the heap. You recreate one. So basically, you didn't create a new object. You just cancel a link and bring back a new link. Okay. So did we go over the
Seven true or false?
Oh, 7 is false. We didn't create a new object. We just like I said, we just canceled the link, the reference type from here to here and bring a new one, which is the employee tab. That's how we do the tab casing. We didn't create anything in the heap. Like the heap is keep the same. The only thing changes in the stack. And because Java is a auto garbage collected programming language, so the person will be collected later. So it will come automatically. You don't need to worry about it. It's not like C. You only need to create a new reference type E and point it to the heap. Okay, the next thing we go over is the dynamic banding. It's quite important. So dynamic banding determines which method implement to call at runtime based on the actual object type. I have a question later, but let's go over this one really quick. There is an example object x equal to new point 12. So the declared type is object, obviously, and the actual type is point. For the actual point, you can also call it the running type. So for the println function, which toString is invoked? The running type. So the toString function in point will be invoked because even though we declare it as the declared type is X, but when we're trying to invoke a function, invoke the toString function, it will still go back to the running time function, or running time type, which is the point. So the toString function declared in point will be invoked here. Okay, so next question is pick up from the question set. I think most of you guys has been familiar with it. Just give you like 30 seconds to just read through it, and I will go through it together with you guys. I think this is really great question because it's testing almost everything about casting, polymorphism, and dynamic banding. Oh, we didn't go through polymorphism, right? Oh, okay. So for polymorphism, oh, sorry, I should bring it back. Okay. The polymorphism, I have an example later. So, but I can give you a like a abstract idea. Basically, it just means subclass is a instance of its superclass, but the reverse is wrong, which means you can't the superclass is not an instance of subclass. Okay, let's go through this question together. Yeah, I think I will still go to the board. The first one, beta b equal to beta SCS. I can use the no. Oh, sorry about that. Oh, I can't really use the mouse.
That's your mouse. That's your.
Oh, can you guys see my mouse? Oh, yeah, you guys can see my mouse. Oh, that's great. So here, let's go over it. So first thing first you do is you create a new instance, which is a beta. So you go to beta and your input is CSC. So what happened here is the constructor is invoked and your string is CSC, and it's just use the super function. So what's happened is we go back to the constructor of alpha. You just put a message equal to message, which is pretty simple, and you call the function b bar. So we go here and we found b bar is actually taking no argument. That's the trick point. Oh, okay. It's not for here. So what we do is there is no argument here. So basically, we just invoke this b bar function and it call for B07. So we see there is no for function in beta, right? There's no for. So we go back to the superclass. This is also the dynamic banding means like if you don't have the function in your running time type, then you go to the superclass. And in the superclass, you have function for. Oh, sorry. Oh, it has function for in the beta. Excuse me, that's a mistake. So you have function in your beta. So you call this function, and basically it changed the message to B07. And then you output this and then you output the system like you output this beta, this new beta, and this is the trick point. Actually, it's not like a regular print ln. It invoked the toString function. So if you forgot what is a toString function, the definition is right here. Basically, if you passed like an object to the printl, then it will invoke the toString function. So what we print here is we go back, since we don't have a toSprint be declared in the beta type, a beta object, so we go back to the alpha, which is his superclass, and here is the toString be declared. So if the message equal to null, then we return alpha, but no, we have a B07 here. So what we return is actually here, else return alpha plus B07. So the result will be alpha B07. Let me just put answer here because I didn't put the answer on my slide, so I will just write the answer on the blackboard. Alpha B07. Okay, so let's go to the next one. Alpha A equal to new alpha. We create a new instance of alpha, and then we try to invoke the display message. We go to the display message. Here it is. So we have no message be like we have no argument be passed in here. So if message is equal to null, then we print no message. So the answer here is just basic. There's no message. Okay, let's go to the third one. Same story. We create a new beta CSC, and then we call B bar B07. This is actually the mistake I made in the first one. Here, we trying to pass a message into the B bar, but actually the function the function bar in beta, he doesn't take any message. You see, it's just a blank. So basically, we can't invoke this function. We should go back to his superclass, which is alpha, and looking for the function bar. And here it is. And the function in alpha take a string as a argument. So we invoke the full function. Here's also the trick. So when you're trying to invoke the full function under the alpha, which function is actually being invoked? The full from alpha or the full function in beta? Which method? Sorry, I should say method. Which method being invoked? Actually from the beta. You remember we just talked about in the dynamic binding, because the first thing you should run is your running time. And your running time here is still the beta, not the alpha, because here we construct a type of new beta CSC. So we run the function in beta. Oh, I mean the full function in beta, which is replace your message to a string. So the string is actually which one? B07. So the answer will be just B07. Because, you know, here we invoke the function here. Sorry, we invoke the function here and they call the function here. You can see my mouse, right? And sorry, here. So basically the message be replaced totally. That's why there is only B07 left. The CSC has been covered, totally covered by the B07. And let's go to the next one. Same thing. We create a alpha tab, alpha object, and then we trying to system print out a same story for the toString function. If you invoke the toString function, you need to put your and you have a value. You did have an argument passed in. So which one will be invoked? Of course, this one. Else return alpha plus your message, because you do have a B. Oh, sorry. That is there a problem? Is there a question?
No.
Oh, okay. So what's going on here is you don't have a message. Oh, sorry, that's a problem for me. Sorry. So you don't have any message from alpha, because when you create the alpha object, you pass nothing in there. So what will happen is message equals to null, you just return alpha. So the answer will be just alpha. Okay, let's go to the next column. The declare type is alpha. However, the running time type is a beta. So when you're trying to call the toString function of A, which one will be invoked? The running time type. But however, there is no toString method in the running time type beta. So we go back to his superclass and we put CSC. There is a message CSC here. See, there is a CSC message. So we will go to this else return alpha plus message. Let's change the role. And let's go to the next one. You have two. Oh, you first you have A1 is the declare type is alpha, and you create a alpha CSC. That's the regular story, nothing special. And you have alpha A2, which is you assign A1 to A2. Oh, this is interesting because when you're trying to assign a object type to object type, you are not actually just signing the same, like sending all the information into it. Basically, you just assign the reference to A2. What I mean by reference, you can imagine it as the address. You basically just pass the address to A2. You are not copy and paste everything in A1 to A2. You just give the address to A2. That's the story. And you call the function, call the method A1 for B07. So what happened is the running time of A1 is alpha, and the function is full. So here we go. And the pass argument is CSC. So what will happen is the message will plus the string you pass here. And the next one is, so yeah, so right now A1 has the message CSCB07 because you just add some message to the original message. And let's go to the next line. A2 display message. So basically A2 has the reference from A1. And when we call A2 display message, it actually display message the A1 object. So let's go to the display message. And if the message is to not no, we have something here. So we run this line, system out print message. Yeah, so it's pretty clear. Everything we need to do is CSCB07. Just like I mentioned, I'm not sure. Should I spend some time? Yeah, I think I will spend some time on the primate type and object type later. So I will draw some memory model at that time. So let's go to the last question. So beta b equal to new beta CSC and b4. So basically we're calling the function, calling the method from beta and B07. Yeah, and the message is being covered to B07. So the CSC is gone, only B07 in the message. And then we print B. So same story. There's no toString function, a toString method. So we go back to here. So we do have a message. It's not null. So alpha plus the message B07. Yep. Is that clear? I think the camera is a little bit too far away, but I can't really move the table. About that. Okay. Let's go to the next question. Overloading and overriding. This is pretty simple. We shouldn't spend too much time on it. Let's just go over the questions. So which output is following code will output? Yeah, let's just go through it together. We don't have too much time. So basically the driver is where we execute everything. Here we declare a b equal to new b. Yeah, the very tricky one. I mean, the still same old story. The declare type and the running type are not same, but we are too familiar with it. And we're calling the function from B, B4, and we run with the running time is don't forget about it. The running time is B. So we go here, and we found there's no for, and then we go back when we go to the superclass and we find the function full here, and we running bar. So don't forget that the running time is b. Don't be messed up here. So we're calling the bar from the running time b. The bar is here, x minus minus. So actually, what will return is, I mean, the value of x will be 5 minus minus, which is 4. So when you're trying to when you're trying to print out the bx, what will be eventually on your console? I mean, the final output is 4. Okay, let's go to the next one. Yeah, super keyword. I don't think we should spend too much on it, but there's one thing you need to be familiar with, which is if a class is designed to be extended, you should better just provide a non-argument contributor to avoid programming error. Why? Because a constructor may invoke an overloaded constructor or its superclass constructor. If neither is invoked explicitly, then the compiler will automatically put a super bracket as the first statement in your constructor. So just in case something will happen like that, so to avoid something happen like that, you better just make a non-argument constructor for your superclass, I mean. Yeah. And the object class, the object class has two string. Two string, we just covered two strings. So let's talk about the equal. Basically, there are 4 general contracts for equal: reflective, symmetric, transitivity, and consistent. Let's just use a question to go over these 4 ideas. Oh, I think the question 10 is not really about equal, but more like testing on the primate type and object type, the difference between a primate type and object type. Yeah, just read through the question, or we can go through it together. Okay, so what would be the result in each of the following case? M1 equal M2. Let's see what is M1. You create a M1 new class 1 and M2 equal to new class 2. So question 10. So I think it's pretty clear it's a false one, because the value is not same, and value 1 equal to value 3. Value 1, sorry, I mean M1 equal to M equals M3. This should also be a false one. Can you guys tell me why? Maybe just put your response on the chat. Do we have any?
Someone said don't point to the same object on heap.
Yeah, exactly. And let's go to C. C is correct. M1 equal to M4 because you have declared M4. I mean, you have to assign the reference to M4. So basically, yeah, you have them equals, and M1 equals to now is absolutely false. Okay, let's go this question. This question is really testing about the 4 contracts about equals. Just give you like a really quick review of this question, and then we will go through it together, okay? Okay, the first one, reflectivity, which means we need to make sure x equal to x. For this one, I think is most of time is correct. So A is right. and B, symmetric. So what symmetric? It should be like if you have x equal to y, then you should also have y equal to x. This is also correct. Yeah, I don't think we should go through symmetric too much because it's most likely it is correct. Maybe sometime they will make some question about symmetric and get you to find some error, but most likely the question will be about transitivity. So for transitivity, we need to make sure if x equals to y and y equals to z, then we need to make sure x also equal to z. But for these cases, it's not the truth. Let's see why it's not right. So you need to come up with a counterexample. That will be really great. So I have my counterexample using a D and SD. So D for duration and SD for specific duration. So you can have SD1 equal to D. And sorry, you have to declare some basic stuff for them. But the main idea, let's just go through the main idea. I will write it on board. Do you guys have the answer for it? So I will just resolve them and give you a basic idea to show why it's not true. So let's say you have SD1 and D and SD2. So clearly SD1 and SD2 are specific duration. And the D is just duration. This one is also the specific duration. So what you're trying to find the counterexample is SD1 dot equal D is true. And D equal SD2 is true. But SD1 equal SD2 is false. How does that happen? A very brief idea is, let's see what specific duration has, but duration doesn't, which is second. Sorry, not seconds, millisecond. Specific duration has millisecond. Sorry, the specific method have a extra field which is milliseconds. So we want to make something about the millisecond to cause the contract here. So when we're trying to compare the first SD1 to D, we will go to just follow my mouse here. We will go to the object is an instance of specific. Yeah, we try to invoke the function from SD1, which is a specific type. So we invoke the function here. The comparison will happen here. So we will find the object is super equals object. So we basically use the equal from his superclass. So we go back to here and we do the comparison in duration class. Let me see where, here it's the equals. And we find the superclass is an instance of, the subclass is an instance of his superclass. So we return true. Oh, sorry. Yeah, here it is. So we just compare the minutes and second, and we found their minute and second are same. So this would be second minute equal to x and y, and d second minute equal to x and y, but d has a special one, which is millisecond, ms. Let's just say equal to Z, but he doesn't have. But for SD2, as I am S, we can have the exactly same second and minute. I'm not sure if this one is, maybe this one is out of the screen, but we can have a different MS, let's say W. So basically, this is the counterexample. And let's quickly go through the other one. The hash code. So for hash code, you have to output the exactly same value if you invoke the equal function and you got their equal. For example, you have A and B. You call A equal B and they return true. Then you have to make sure their hash code function return the exactly same value. So there are some good practice or there are some bad practice. For example, the A is actually the correct one. As long as you make sure they are equal, then it's work. But it's really a bad practice because no matter what, it will return 100, but it's still correct. And how about B? It's also correct. Because we return the ID. So for the stuff is employee, we want to compare to employee, right? The only thing we trying to compare is his ID. We don't really care about their department. So if you return the ID, I mean, if you have two employee with same ID, then their hash code should be the same. So if you just return the ID, two same employees should have the same ID. It works, and I think it's a good practice of hash code. And C is actually wrong because it adds the department hash code. So for just like I mentioned before, for because we're comparing employee, we don't really care about their department. We only need to make sure their ID is the same. So that's the wrong one. And the D is the same problem. It also trying to include the department hash code, which is not even a concern point of our problem. So the answer for this one is A and B. The definitions here, if you need it, you can take the screenshot. So abstract class. So for the following one, which is valid, which is not, just take a quick look of it and we will go through it together. Okay, first the A is correct, right? There is a concrete method for, and it's a lot. In an abstract class, you can have you are allowed to have a concrete method. There's nothing wrong with it. And B is definitely wrong because you didn't have the abstract modifier. You have to be public abstract class my class, right? Because you have an abstract function, then you have to make sure your class is also abstract. And C, is that C correct or wrong? It's correct. Nothing wrong with it. You have abstract class and then you have abstract method. Nothing wrong about it. How about D? D is also correct, right? You have an abstract class, you have an abstract method, and you have a concrete method. That is allowed. You can have a concrete method in your abstract class. And how about this one? Interface. Indicate whether it's valid or not. For A is correct. You have an abstract class in your interface. Yeah, that's allowed, but you cannot have a concrete method in your interface. How about B? You just have an interface and you have nothing in it. That's not wrong. You just don't have anything in it, but there is nothing will cause an error or there is nothing will cause a warning. And C. Okay, C is a little bit tricky. Most of people will think, oh, probably nothing wrong about it because you can have a constant. Yeah, of course you can have a constant, but the problem is about the constant. So here you only declare X as an int, right? But if you have a constant in your interface, you should declare it as a final. So maybe not only final, you should also have some modifier like public, static, final. So basically, this C is wrong because you only declare X as an int. you should declare it as a static final. And there's another way to declare it, which is just using, the sorry, I need to erase that. There's another way to declare a final or declare a constant, which is kind of like that. You got an idea? Using the capital letters. That's another way if you just trying to use int and have a variable. Here. So if you really want to just use int, then you have to make sure your variable is totally capitalized. Otherwise, you have to make sure it's public. Oh, this one is not really, this one is not really necessary, but static and final, which means you can't modify it. The value is constant. You can't do anything about it. You can't change it. You can access it, but you can't change it. Yeah, just like I shouldn't write on board because I have it on my note. Yeah. So let me see the time. Oh, we're a little bit running over time, but just we have a generic interface, generic classes, and generic method. For generic classes, you should import it from the library. But I'm only going to talk about the interface because there is a very famous and very oftenly used interface, which is comparable. So how do you implement the comparable? You just the just the highlight part. You just implement a comparable, and you put your point or string or the type you want to compare inside it. And oh, sorry. Oh, is that all? Okay. Yeah, and you declare you override the function, you override the method compare to, and whatever you want, and just don't forget to follow the rule, which is if you return a negative, which you have to return a negative integer, 0, or positive integer, and make sure they are matching, which means if it returns a negative an integer, it means less than, and it returns 0, it means equal to, and it returns a positive integer, it means greater than. That's all you need to be aware of. Just don't output a positive integer for like they are less than. That's totally make no sense. Yeah. And exception. There is one special case for exception is running time exception, because it's also known as the unchecked exception, which means the compiler will not force the programmer, which is you guys, to check and deal with it in a try catch block. That's probably also the reason why we make a lot of error, like a running time exception error during our coding, because the compiler will not force you to do the try and catch part. And for the rest of exceptions, they are checked exception, which means you have to make a try and catch block, otherwise it won't run. It will give you a warning. And declaring an exception is pretty simple. You just follow the public void my method and throws your exceptions. You could have a lot of exceptions, and just make sure you put them together. And if you throw in exceptions, throw new exceptions, and you have your exception message in the bracket. If no exception arises during the execution of the try block, then catch block will be skipped. And the Java has a finally clause, which means no matter of what, no matter of there are some exception be catched or there's no exception be catched, it will still run the final clause, everything in the final clause. So let's have a practice on exception. So for this one, you have a class fraction, and if denominator equal to 0, sure, it's elementary school knowledge. You can't have a 0 as the denominator. So if there is a denominator equal to 0, then you throw the exception, denominator cannot be 0. So in the execution part, you're trying to create a fraction 1, 0, which is violated. And what will happen is there will be exception throw, and it's the exception EX. So the exception EX will be cached here, and it will print second catch block. And then there's no running time arrow. Of course, you don't have an array, you don't have an array list. There's nothing will trigger a running time type arrow. So basically, you only the compiler will only give you a message second catch block and then run the finally clause finally blocked. That's the only message you will got. And the denominator cannot be 0, won't show on your console because you didn't have a ex dot get message. You didn't have you didn't call for a function to print out the message for the arrow. That's why you don't have a denominator cannot be 0. Okay, that's all for the OOP. I think we run out of time, but I'm really willing to really quickly go over the first part, the chapter 1. So if you want to stay here, I will use probably like 5 to 10 minutes to go over the first chapter. So, but if you are not interested in it and you feel it's not really useful or you feel really confident about it, then you can go. Just give me a sec. Okay. So, what is Java? I don't think there is a question about what is Java, but maybe you guys know Java is an island in Indonesia. That's why that's the resource of the name of Java. And let's talk about the memory management. Like I mentioned before, the Java has a very great automatically memory management, which means you don't have to in your stack and in your heap, you don't have to collect the trash and deal with the trash data. They will be collected automatically, and there's no pointers. It's not like C. You have to keep pay attention to your pointers, and they point around, and everything in your memory model is heap and stack, like I mentioned, and the use case is you guys have our final project. It's most likely the application in Android or website or maybe iPhone. So Java program has 3 main steps: writing our source code and translate it to a byte code and then execute the bytecode. So there is a question about how to compile your source code to bytecode and then compile your bytecode to the Java the Java code. So this is a little bit unnecessary because most of you guys will just compile it without compiling it to bytecode. But let's just do it. So the first one is Java C welcome.java. This is how you compile it to a bytecode. And you just, when you're trying to compile the Java code, run the bytecode and make it and result everything, you just call Java welcome. And same ideas. So Java bytecode will be executed by which? Java compiler or JVM? The JVM. The bytecode will be executed by JVM. And you let's go back here. The bytecode. Oh, sorry. The bytecode will be Java bytecode. Yeah, the bytecode will be executed by JVM, but the bytecode came from. Oh, wait. Executed by JVM. Yeah. The bytecode will be executed by JVM. Bytecode. Yeah. Okay. So let's talk about the data type really quick. Which are not primate type. There are only 8 private types. So the string and the array list are not. So you have the 8 primate type here: byte, char, short, int, long, float, double, and boolean. And the objects are defined using classes, like the point, like the example we have employee. They are object type. And the classes Okay. A typical classes include the following: data field and the method and the constructor. That's pretty simple. And I want to talk about the static one. See the right arrow? I want to talk about static. What is static method? So static, some key characteristic of static method is class level association. So basically, you can only access it from the class itself, not individual object, and no access to instance members and invoke using the class name. Yeah, that probably you will be tested on using class name. Like if you want to invoke a static method, instead of using the object name, you should using the class name to invoke it. Yeah, let's do a question. We're trying to invoke static type. How will you implement it? For example, you want to invoke function hello print hello. So basically, you will use the class name. Sorry, you will use you will invoke it using the class name. Sorry, the cycle is the circle is here. Basically, circle is the class name. So you're trying to invoke the static method print hello. You need to put circle. Sorry, I write it cycle. I'm sorry about it, but it should be circle. When to use static method, when the behavior of your method does not depend on any instance variable or method of the class, which means it is very important, which means in your static method, you should not include any variable which is not a static variable, which is not a static in the like it's a static one. Because when you're trying to access it, it has to be not modifiable, which means it should be constant forever. Yeah, you can modify it from the class, but you can't really access it from his instance. You can access from instance, and you need to make sure no matter which instance you're trying to use, you will also get the same value, you know. Here is example to creating an object. For example, the circle new circle. Yeah, there is one thing to be mentioned. The data field has default value. Java assign no default value to the local variable inside the method. So which means you can have no value here. And but yeah, you can have nothing here. And if you create a new object, yeah, let's draw how you create a new object. Yeah. Memory model. And you have stack and heap. So in your heap, you have all the objects. Let's say C1, C2, and P1, P2. String 1, remember string is also a object type. String 1. And what else you have? Yeah, maybe let's say you have array stack. Yeah. And what's inside your stack? Into two and character, right? Char and double. Those are primary type. Sorry about that. Those are primary types. So you just store in the stack. And what else you have stack? Remember, we just talked about it. You have the reference for the object. C1's address. Remember, it's not an object. It's just a reference pointed to here. Not really pointed. I mean, it just represents where you store the C1 in heap. And what else? You have all the method. Method 1, method 2. Yeah, that's how it looks like in heap. So when you're trying to create a new instance, like for example, you create new circle. Let's zoom in here. You create a new circle. You have C1, and this type is circle, and you have center. You have what else? You have radius. And now we need to assign some value here because you assign no value, so the default value will be null, and the default value for radius will be 1 because radius is int, right? And center is a point. A point is an object. So for object, the default value will be just null. You point it to nowhere. But for an int, the default value will be 0. So the question, which method is the entry point where the program begins to execute? Pretty simple, right? The public static void main. You need to remember how to write it in the correct order because I know you guys using the VS Code or whatever. They will just print it out for you. So you need to know how to write it if you write on paper. So what is the scope of field and method? Just filling a blank question. What is it? The entire class is the scope for field and the method. So what is the scope? Scope is like, for example, the scope for a local variable start from its declaration until the end of the block. Let's say a for loop. If you have a variable in a for loop, then you cannot access the variable outside the for loop. You can only use the variable inside the for loop. That's the scope for this variable. And this is how scope defined. Just basically give you a range, you can use this variable or you can access to some particular stuff. And outside this range, it's not accessible. And yeah, the primate type and the reference type is just like we mentioned before. If you assign a primate type to a variable, you just assign the value, you copy the value to the variable like here. Like if you assign I to j, basically you change the value of I to the value of j. So j is equal to 2, so now I is equal to 2. But for the reference type, you're not really copy pasting the actual value. You actually what you do is giving the reference or the address to the variable you assign to. For example, here you assign C2 to C1. What you actually do is you're giving the C2 address to C1. So C1 is no longer pointing to C1. C1 now pointing to C2. Again, the pointing idea is wrong for Java. It's only for your understanding. There is no pointer in Java, but just for your own understanding. And the output input, I will recommend you to know at least 2 ways of reading and at least 1 way how to write, because there's probably going to be a coding, like a big coding question to let you read something and then print something. At least in my final, I remember very clearly, in my final, there is a question to use to read some file and print something. So here I have an example of scanner. I won't go through it because the time is quite late. But I would recommend you to have buffer reader. You need to know how to use buffer reader and scanner, and then you need to know how to use print stream to write. Yeah, this is the output. Yeah, that's all for my part. Basically, we go over all the material before the midterm. And for the questions, I think we can upload our slideshow to the Discord community of AMACSS, and you can find all the questions there. Is there any questions? And thank you for staying with me for so long. We run over time for 20 minutes.
Yeah, thank you guys so much for showing up to the review seminar. Again, if there's like any conflict of interest, make sure you follow Professor Rawad or the TA's method, just to make sure like you don't get any misunderstanding. Okay.
So we'll be attaching a feedback form in the chat. Can you please take your time to fill it in? It will be used to improve future review seminars. If there's no more questions, then thank you all for joining us today this late, and best of luck in your exams. Thank you.